I will be showing you how to solve the 1998 AP Chemistry Free Response Question 5. An approximately 0.1 molar solution of NaOH is to be standardized by titration. Assume that the following materials are available: clean, dry 50 milliliter burette, wash bottle of distilled water, 250 milliliter Erlenmeyer flask, phenolphthalein indicator solution, analytical balance, and potassium hydrogen phthalate, KHP, a pure solid monoprotic acid to be used as the primary standard. Part A. Briefly describe the steps you would take using the materials listed above to standardize the NaOH solution. Part A. Your first step would be to take the mass of the potassium hydrogen phthalate, KHP, using the analytical balance. Then place the KHP solid in the 250 milliliter Erlenmeyer flask and add distilled water to dissolve it. Next, fill the clean, dry 50 milliliter burette with NaOH solution. Add phenolphthalein indicator solution to the flask, only a few drops. Titrate until the endpoint is reached. You will know you've reached the endpoint when there is a change in color. Make sure you have all these steps and that all the materials listed in the question are used. Part B. Describe and set up the calculations necessary to determine the concentration of the NaOH solution. The first calculation you would need is the mass of the kpH divided by the molar mass of the kpH. This will give you the moles of kpH. You know that the moles of kpH will be equal to the moles of NaOH because it is a monoprotic acid. After that, you can take the moles of NaOH, which will be the same as the moles of KHP, and divide it by the liters of the titrant. This will give you the molarity of your NaOH. Part C. After the NaOH solutions has been standardized, it is used to titrate weak monoprotic acid, HX. The equivalence point is reached when 25 milliliters of NaOH solution has been added. In the space provided at the right, sketch the titration curve showing the pH changes that occur as the volume of NaOH solution added increases from 0 to 35 milliliters. Clearly label the equivalence point on the curve. Now for Part C, your curve should look something like this. The volume of your NaOH added should be on the x-axis and go up to 35 as said in the problem, and the pH should be on the y-axis. Your curve should start at a pH above 1, less than 7. Equivalence point should be at 25 milliliters and at a pH greater than 7. Part D. Describe how the value of the acid dissociation constant, Ka, for the weak acid, HX, could be determined from the titration curve in Part C. So using the curve that you drew in Part C, you can find the midpoint of the titration curve. Once you find the midpoint, you can find the pH. The pH will be, at this point, will be equal to the pKa. Just take the pKa and plug it into the equation, pKa equals negative log of Ka, and you can find the Ka for the weak acid. Part E. The graph below shows the results obtained by titrating a different weak acid, H2Y, with the standardized NaOH solution. Identify the negative ion that is present in the highest concentration at the point in the titration represented by the letter A on the curve. A, right there. So, your answer would be y negative 2. It would be y negative 2 because the curve clearly shows that two titrations are taking place because of the two equivalence points, here and here. The first titration would have the highest concentration of the first ion in H2Y, which would be the H-. Because point A is located in the second part of the titration, the negative ion that is present in the highest concentration would be the second ion, y negative 2. Therefore, your answer for this question would be y negative 2. That is how you solve the parts of the 1998 AP Chemistry Free Response Question 5.